მოგესალმებით, ძვირფასო მაყურებლებო, თუ ახლა გიყურებთ, ჩვენ ესე იგი Facebook Live-ში ვართ, ან თქვენ ხართ ჩვენი სტუმარი Zoom-ის შეხვედრაზე. დიდი მადლობა კიდევ ერთხელ და მოკლედ გაგაცნობთ ამ ღონისძიებათა სერიას, ეს გახლავთ Technova, რომელიც ორგანიზებულია ილიას სახელმწიფო უნივერსიტეტის Google-ის დეველოპერთა სტუდენტური კლუბის მიერ, ნეგარ ვაჰიდის ხელმძღვანელობით, რომელიც გახლავთ ჩვენი უნივერსიტეტის მესამე კურსის სტუდენტი კომპიუტერულ ინჟინერიის მიმართულებით. დღეს ჩვენ გვეყოლებიან ორი ძალიან საინტერესო სტუმარი, მიშა ციკლაური, კომპანია Apple-ის ტექნიკური ლიდერი და ასევე პროფესორი ულრიხ ჰაუზერი, რომელიც ჩვენმა უნივერსიტეტმა გაიცნო 2019 წელს, როდესაც ის სტუმრობდა საქართველოს და იყო მოწვეული ლექტორი. პირველი მომხსენებელი იქნება მიშა ციკლაური, რომელთანაც ნეგარ ვაჰიდი, ჩვენი Google-ის დეველოპერთა კლუბის ლიდერი, გამართავს ინტერვიუს და შევეხებით უფრო ვრცლად კომპიუტერულ ინჟინერიას ამ ინტერვიუს განმავლობაში. მოკლედ გეტყვით მიხეილზე, რომ იგი 2012 წელს შეუერთდა მისურის სამეცნიერო ტექნოლოგიურ უნივერსიტეტს, როგორც მკვლევარი პროფესორი და 2017 წლიდან ის მუშაობს Apple-ში როგორც ტექ ლიდერი და ავითარებს ალგორითმებსა და მათემატიკურ მეთოდებს სხვადასხვა ელექტრომაგნიტური პრობლემის გადასაჭრელად. ახლა მე გადავალ ინგლისურ ენაზე, რადგანაც ჩვენი დღევანდელი შეხვედრის ენა არის ინგლისური. Hello everyone, thanks for joining. This is Technova event series for tech-curious people organized by Ilia State University and Google Developer Student Club from Ilia Uni. And the leader of this club is Negar Vahid, the third-year student from computer engineering. We have two guests for today, Misha Tsiklauri and Ulrich Hauser. Misha is the Apple tech lead and Ulrich Hauser is the professor from Grisons University from Switzerland. Now I will give the stage to Negar. She will dive into the details with Misha about computer engineering, and we will have this honor to listen to this conversation. Also, I want to mention that Facebook Live is open for everyone, or if you're a Zoom guest, you can just type your question in the thread and we will answer on that. We will also have a direct Q&A session with the audience. Thank you very much and good luck.
Thank you, Tiko. Hi, everyone. I'm Negar, Google Developer Student Club's lead. And I'm really excited actually today because my first guest is Misha Tsiklauri, I think. I'm sorry if I'm butchering your name. This is going to be an interview. It's not going to be a lecture. And I'm going to be asking questions from him. And of course, after my questions are over, you guys can ask questions and we will, answer your questions. So, hi, Misha.
Yep. Hi, Negar. It's nice to meet you and have interview with you.
Yeah, thank you so much for being here. So, Misha, can you introduce yourself in your own words?
Yeah, so my name is Misha Tsiklauri, and right now I'm working with the Missouri, with the Apple. Before I was working with Missouri University of Science and Technology. My major is in applied mathematics. I got all my degrees, bachelor, master, and PhD with Tbilisi State University, Ivan Javakhishvili Tbilisi State University. It was a long time ago. I started university in 1994, and that was very, very long time ago. And I received my PhD in 2003. So as I mentioned, my major is applied mathematics. Then I was working as software developer, and later I started working with electrical engineering.
Okay, that's amazing. So you did all your degrees in Georgia, which is very impressive. Okay, so you mentioned you were a software developer before you joined Apple. Can you tell us about that?
Okay, so in 2000, I got my master's degree. And I started working with Tbilisi State University as a lecturer, and also I was working with Ilya Vekwa Institute of Applied Mathematics as a researcher. So, and in parallel, I was doing my PhD. So during this time, I was developing different mathematical methods, and I was doing some programming also. In 2003, I got my PhD, and I still was working as a lecturer and a researcher, but at that time I joined company. Company name is Geographic, and I joined as software developer. So this company was doing digital maps and was doing some geoinformation system analysis. And I was working as a software developer, and I was developing different tools for special analysis. For instance, I was working to develop a system that was trying to optimize facilities, medical facilities that can serve many people. So coverage should be large and with a less amount of facilities. Also, I was working with Georgian aeronavigation to find the best locations for radars that can have a largest coverage, and with different city developments programs. So everything was related with a special analysis, and I was developing software tools to optimize different goal functions. So and later, when I joined Missouri University of Science and Technology, I still was developing software tools, but in this case, it was related more with electrical engineering.
Okay, so you kind of moved from programming into engineering in that sort. Okay.
Yes, but still, even in Missouri University of Science and Technology, I was developing software tools,
Right.
but it was related more electrical engineering.
Very interesting. So I'm sure a lot of people have this question of how did you exactly, like, okay, so you got all your degrees from Tbilisi, you studied applied mathematics, which this is the proof that you can study mathematics and be successful, just out there. And I think everyone wants to know, like, how can you even enter the community of Apple? Like, how did you do it?
Mm-hmm. Okay, so for this, I need to start from Missouri University of Science and Technology. As I mentioned, in 2003, I started working with the Geographic in Georgia, and I was working there for 9 years. In 2010, I was contacted by Alex Razmadze. He was working as a postdoc at Missouri University of Science and Technology. They were developing software tool for different electromagnetic problems. So this tool called FEMAS, Fast Electromagnetic Analysis Suite. And they were looking for a person who can do scientific computing. So they already had also Georgian guy who was doing GUI, who was developing GUI, Alex Shaduri, and they were looking for someone who can do scientific computations. And they contacted me, and I agreed. It was a pretty interesting project. I was working, I started working in 2010 summer, and I was developing algorithms and modules for different electromagnetic problem solution. So actually, at this time, I still was working with the Geographic, and I was still doing lectures. So it was pretty tough period. I was finishing my day job at 6 p.m. and I was starting working with Missouri University, and was working until probably 3 a.m. night during more than 1 year. There was also almost, it was probably 10-hour difference. So when there was a day in Missouri University, there was night in Georgia. So I was working 1 year, and after 1 year, Missouri University of Science and Technology, they offered me to join that university as research professor. and I agreed. And in 2012, I moved there. So I started kind of a new life. I joined as a research professor, and I was still doing same similar job. So I was working with algorithms and developing software modules for that tool. And this university, so there's lab, EMC lab. EMC is for electromagnetic compatibility, and this lab has a unique experience. There is consortium with this lab. This consortium was funded by American National Science Foundation. And in this consortium, it's a project, and the name of the project is University Industry Cooperation. So the idea is that a consortium is created with several universities. With Missouri University, there was also Houston University and Clemson University. And in that consortium, we had about 25 companies, industrial companies, such as Apple, Google, Amazon, Microsoft, and Dell, Cisco, and almost all high technology companies. So how this system is working, those companies are paying fee, yearly fee, annual fee, and they are bringing projects, and university professors and students are working on that project. So they are paying less money than they can spend for a single engineer, and they are getting, first of all, they are getting results from the project. Second, also they are during 3-4 years they are working with students. And later, those students can join their company. So those students are prepared for them. So during this time, I created a pretty interesting network. And I already knew people and managers from Apple, Google, and other companies. And that helped me to join Apple. Actually, before, when I decided to go to the industry from the university, at the beginning, I was going to join Cisco. I had offer from Cisco, and before joining Cisco, then I received another offer from Apple, and that another offer was more interesting, so I decided to join Apple. So I would say that intermediate step was that university where I got pretty good experience, and also good networking that helped me to find this job with Apple.
Yeah, that's very interesting. So networking and experience, who would have thought? Yeah. So I think a lot of people kind of skip this part of networking, and like like myself recently, I realized how important networking is. Like it's huge. Like literally, like you can find jobs that you dream of, like that easy. It's not easy, but you get the idea. Actually, this is just kind of a question that I'm curious about. How diverse is Apple? Meaning, like, from which, like, are they mostly American, or what is happening?
Okay, so I'm in US. I'm from 2012, right? It's on like 9 years. Yeah, it's 9 years. And people I was working mostly are outside America. So they are from everywhere. At Missouri University, all our students were either from China, India, Georgia. We had pretty like 3-4 Georgians from maybe 30-40, about 10% Georgians.
Okay.
That's pretty pretty high number. Yeah. And just a couple of Americans, couple US students. Everyone were from China, India, Iran, some of them from Russia and Georgia. So, and even at Apple, when I joined Apple, we have in our, we call EMC design team, EMC design engineering team. Here we have more than 50 people, and probably 5 of them are American. Yes, citizens. All others are from China, again, India. We are 3 Georgians. That's also pretty.
That's amazing.
Yes.
That's impressive. Okay.
And actually, interesting thing is that all these 3 Georgians, all of us, are related with Missouri University of Science and Technology.
Ah, so it starts from.
And yes, and from these 50 people, maybe 10, more than 10 are from Missouri University of Science and Technology. So they are either my students or they joined before me.
That's very interesting. Okay. That's actually what I thought like was going on in Apple. Okay, now.
Actually, not only Apple, in Silicon Valley, most people are people who are working in a technology field. They are outside US, mostly outside US.
Okay, so we all have a shot, guys. We can do this. Okay, so now let's talk about coding, because actually briefly you were my professor in our university, and you told me something very interesting, which was don't just code like efficiently and creatively. So can you like tell us just elaborate on that a little bit?
Yeah, sure. Okay. When you are coding, I would say first thing what you need to do is imagine that at any moment you can stop coding and someone else should continue. So it means that you need to code in such way that everyone should understand. The most difficulties I have when I need to continue or try to understand or see some code, and I need to continue or understand what is written inside, because it's not easy to understand, right? That someone else's code. So the most important is to write in a such way that everyone can continue writing. You know that big projects, you cannot develop big projects alone, right? Big projects are developed by team, and usually there's a teamwork. So if you are coding and you say that, okay, I will code this, and I know what I'm doing, and I can easily finish it, but you never know. You might be asked to stop and switch to different project, and someone else should continue. So it should be very clear what are you writing. It should be very simple, and try to write as few lines as it is possible. Don't write huge thousands and millions of lines. That's one part. Another is that you should think that every time when you are starting writing some code, probably you will spend 20% of your time for coding and another 80% for debugging, trying to find errors and fixing them. Yeah. So if you will write, if your writing will be complicated, it will be too difficult to find error. So you need to split your code, right? Organize in a such way that to be easy to find the error and for debugging, to be easy for debugging. Of course, you need to wisely use comments because you will not finish this program in a couple of weeks or months. You might work with years, and even when you're writing some software, you should be prepared that next year or after some time you will need to do like a next version revision, update, add some other functionalities. So maybe you remember very well what you are writing now, but definitely you will not remember in a year what you are writing, right? So you need to use wisely comments and organize in a such way to be easy to extend. That's and especially if you are writing some software that is related with computation, it's very important to write it efficiently, and it means that write and solve the problem with less number of operations, because people are impatient. They don't want to wait too long, right? And you need to find the best way to minimize number of operations. If you are writing and calculating some different parameters, you need to understand that if this parameter can be calculated once and then can be reused, you need to do it. Don't calculate again and again. So be careful with your loops, and remove outside those loops everything that can be calculated once. Also, sometimes if you're doing scientific computing, you can think that you can maybe you should find the best ways to work with best libraries that can work with the matrices and these mathematical computations that can do as fast as it is possible. So that's some kind of hints what I would suggest to think. And one more thing, when we are trying to solve some problem and you're starting writing, spend more time for planning. Don't start writing. Think more and think more and find the most efficient way to write it. Don't start writing directly. Think more, because you can think that, okay, I will write it and that's okay. It's not okay, because you're writing, then you need to add, and if you write something inefficiently, then it will be pain tomorrow and after 1 month. So spend more time for planning.
Yeah, that's very good advice. Like I'm literally like writing things down so I can look at them later. Yeah, thank you so much for that, because like me, for example, I always just start coding. I mean, obviously I plan it in my head, but I don't think that's enough. So yeah, thank you for that. Okay, so now let's talk about Apple a little bit more, because I'm sure everyone wants to know more about it. What do you think Apple is looking for as an employee?
Okay, so Apple looks for many things. It looks from starting from junior engineers up to managers and senior managers and vice presidents and so on. So let's focus at the beginning of the career, right? Especially the people who are just graduating. Now, of course, no one is expecting that the person who just graduated from the university is a professional and knows everything and have huge experience in practice. We don't expect this. But what Apple is looking for is, first of all, especially for new graduated students, right? First of all, the ability that they can learn. So there are interview processes, and during this interview, everyone is looking if you are ready to learn and if you want to learn. So that's first part, because at the beginning, when you are joining a company from the university, you need to learn a lot. And if you can do it and if you are ready to do it, that's first part. Second part is, as I mentioned, no one is doing job alone. So you will need to work with team, with other groups, with inside the same team, but also sometimes you are working with completely different groups. So they are looking if you are a good team member, if you can work well with teams, you can learn from other members of team, and you can share your knowledge. So working with team means several things. First of all, you should be able to share everything you are doing with inside your team. Second is you need to learn from your team, and third is you should be ready to help others. So teamwork and how you will fit inside the team, it's very important. And third one, what is also important is if you are motivated. Every time they will ask, why do you want to join Apple or any other company? And you need to show that you are motivated, you thought about this, and you want to do something great. You should show you're ambitious, that you want to achieve something, and motivation is also very important. So I would say show teamwork, motivation, and ability that you can learn. And of course, you will have some basic knowledge you got from the university, and that also good to show that you already learned something. Along with theoretical knowledge, it's very important to show that during your university study, you have done some practical work. So everything that I was described before, like teamwork and ambitious, all these you can show with your some projects, right? There are university projects where maybe there is something small, but practical thing that you already were working with real problem. You are trying to solve it. You are working with your team, and show how excited you were when you're trying to find different solutions.
Okay, yeah, that makes a lot of sense. Actually, yeah, I have a question about this, having something in your CV that you have done, like practicality, basically. I think a lot of people are waiting for some miracle to happen, and like they get like a very like massive Google job when they're studying, and that's gonna count as something practical. But do you think just working on a project that you're interested in will count as practicality?
Yes, of course. That's very important, working with the project and voluntarily working on project. That's during when you're a student, yeah, probably that in sometimes and many times those projects doesn't bring money to you, right? It's you are doing something voluntarily. But yeah, showing that you are ready to do something real, and you have done maybe very small but practical and real, that and if this result of this project somehow is working and doing something, that's even great. And also that's okay to show that during this project you failed, and show that fail is not something that is catastrophic, right? You can show and tell what did you learn from this failure, and how did you solve the problems, what mistakes have you made. So all these things, to be honest, and showing that you were working, because you don't make mistakes if you will not do anything, right? If you're sitting home, there's zero mistakes. But when you start working, you will get mistakes, you will make mistakes, and you'll have these mistakes also at the work. And that's not a problem. When you're working, the important thing is that be ready for this mistake. Don't hide this mistake, because if you are hiding this mistake, then it will appear after like months and years, and it will be more difficult to solve it. And another thing is every mistake can be opportunity to learn something. So you need to analyze with your team. You need to talk about your mistakes and failures, and understand how to avoid them next time. So everything we are learning with mistakes, right? So
Yes,
we
absolutely.
need to be ready and don't afraid.
Yeah, exactly. So because we're bound to make mistakes eventually because we are doing something. So yeah, that's great advice. Thank you. Now let's a little bit focus on you. I saw an article that you have actually like you have an invention that was recently published. So can you like tell us about that?
Okay, yeah. So as I understand, you are talking about a couple of patents that have been published like probably this year and previous year. So this patent was related with radar technology that can be used indoor, and it was related with tracking target. For instance, if you are wearing some equipment, let's say phone or some other equipment, you can track a person, right? Because from a Google Map or different apps, they are identifying your location, and you can be tracked. But the idea is, what if you don't wear any equipment, right? You don't have phone and so on indoor. How is it possible to track that person? So why it can be used? Because at your home, if you are walking and different devices knows where are you, they can work better. They can beamform audio in your direction, and there might be many different applications. So usually radars are used for tracking, right, in military and other applications. If you are using only one radar, it can just tell you what is the distance between you and between radar and target. So how it works, the radar is transmitting electromagnetic waves. These waves are reflected from the object and coming from the target and coming back, and time of flight tells you how far this object is. But it doesn't tell you your location, right? It just tells you distance, so it can be the target can be at any location on the radius of this distance. So now to also find the exact location, you need more than one radar arrays. So we were doing something similar, but indoor. So using those radars to track the target, identify its position, also based on the radar signal signature, you can understand if this person is standing, sitting, also monitor his breathing and so on. So now mostly it was related with target tracking using radar technology.
That's very interesting. Cool. Okay. So thank you so much for being here. I think my last question for you, like for me, is that if you could give an advice to people who are graduating right now, what would you tell them?
Okay, yeah. So first of all, I want to tell to people who are graduating and also other people who are just starting a study or first, second course. So first of all, maybe it's personal because I'm a mathematician. I would suggest to learn mathematics well, because every problem that you might face at the beginning, it might be related with physics, chemistry, biology, but then you start understanding this problem, and you're trying to when you're trying to solve it, finally you're facing up with mathematics. So all problems are can be translated into a mathematical problem. So basic mathematical knowledge is very important to understand deeply the core of the problem and solve it. So, but when I'm talking about mathematics, I don't mean like adding numbers or integration and so on. It's kind of mathematical thinking or computational thinking that is related with ability to split the problems into subparts and then trying to analyze, find the logic, similarities, patterns, and so on. This is kind of mathematical or logical thinking, and developing these kind of skills is very important. Of course, second part is programming. Software programming is very important. It doesn't matter where you will go. If this field is related with technology, you will need to use your programming skills. For instance, I'm working with electrical engineering problems, and I'm not doing software development for let's say for customers. The softwares I'm developing, they are used for engineers inside Apple to solve different problems. So I'm not kind of software guy. I'm developing mostly algorithms and solutions, but to make these solutions efficient and allow other people to use it, I need to program them and create some tools that will be used by my colleagues and engineers. So this programming skills is also universal, that can be used in many different fields. So those are related with subjects, and of course you need to learn the direction you are choosing. Is it electrical engineering or any field you need to learn. So this is related with knowledge. Beside this knowledge, I would suggest to be more active and create networking. For instance, and go out of your comfort zone. For instance, when you're attending some conferences or some meetings, most time I see that students are grouped together and talking to each other, people you are familiar, because it's like easy, right, to talk to your friends and so on. But this period is very important for creating networks. So you need to go to people you don't know and ask questions and create network. Ask them how did they got a job and what they would advise. So many people like to talk. So when you're asking about themselves, they start talking themselves. They can talk maybe hours. So use this and find the their experience, because every person is unique. They can give you some experience that you can use later. So that's second part. Be active and talk to other people. So and create networking. Third is also very important, curiosity. You need to be very curious, right? You need to be interested. You need to try to find. It's good that we have internet now. You can have answers on many things. So if you're choosing some field, try to find what's happening in this field right now. In university, you are getting basic knowledge and the knowledge that can help you in this direction. But in university, mostly you don't learn what's happening today. And especially related with technology, technology is developing very fast, very quickly. So something that was new yesterday, it's all today. So you need to be curious and you need to be active to find what's happening around. And one more thing, which is very important when you are choosing the field you want to work, right? Try to identify these. You need to think in this way. Let's assume that you already have enough money. You have enough money, you don't need money. Now imagine what you will do for fun, what you will, which field you will go, what you will develop. Yeah. So if there is something you can do without be paid, it means that if you will find this job, that will be first of all, you will work for fun, you will get money, and also that will be the job where you will have most chance for success, right? Because now if you are interested in this and you're willing to work even without money, it means that every day you are working, somehow you are thinking about these problems, and you are spending, yeah, you are spending more time, and you are getting more chances to get success.
Okay, yeah. So now when you were saying like, what would you do if you had money and you were just, you're retired, you want to do, and it got me thinking, and I think I chose the right path. So yeah, okay. We have two questions in the chat. The first one is Misha a member of any international or professional organization? If yes, which one? And in a different age, student, young professional, or above, which are the most efficient organizations that we should consider and look up?
Okay, so I'm a member of IEEE. IEEE is probably the largest organization in electrical and electronic engineering. This helps me in many directions, because there are many conferences that are sponsored by IEEE, and during those conferences I learned a lot. So as I mentioned before, these conferences are unique opportunities to meet people and see what they are doing. And IEEE is making different conferences related with electromagnetic compatibility and signal integrity. And all these high technology companies, they are and universities also who are working with this field are coming, attending those conferences, and they are bringing current projects, the projects that are actual and important today, and even not today, but some of them tomorrow and in 2-3 years. The technologies that will be developed next years, next generation technologies. So you are learning a lot during these symposiums, and IEEE organization is one is EMC symposium, which is every year, and this symposium is happening in US and in Europe also every year. So that's actually the I would say most important organization. I'm still member of this organization.
Okay. Yeah, I'm actually a part of IEEE. Well, I'm a subscriber basically, and the amount of information and events that are happening every single day is crazy. Like, look, you can meet actual experts, you have a lot of articles, and actually like know what's happening right now in the world of technology. Yeah, I totally understand that. And the next question is, what are Misha's future plans and desires after the long distance retirement? How do you want to live when you're not working full time?
Yeah, so right now, next several years minimum, I'm planning to be with Apple, continue what I'm doing. So develop the technologies I'm working with. This is, let's say, couple, minimum 3-4, maybe, I don't know, 6-7 years. Of course, you never know. Tomorrow I might get some interesting offer or opportunities, and I can join different company or maybe even university. But right now I don't have plans outside outside Apple. But actually, For long-term plan, I think that I would like to return to Georgia and share my experience with the Georgian probably students or yeah. So I see my future in Georgia in maybe after 10 years about.
Okay, I think a lot of people can learn a lot from you. Yeah. So thank you so much. Actually, let me see if there's any question in the chats and Facebook. Yeah. Okay. I think we answered everything. So thank you so much for being here. It was really, really great to have you.
Yeah, thanks for inviting. And if my advices will help students, I will be very happy.
I'm sure they will.
Thank you and good luck, everyone.
Yes. Thank you.
Thank you, Misha. It was very, very interesting. When I will comment on the last part that Misha is a member of IEEE, then I want to proudly announce that our university students also become, thanks to Ilya Uni, become members of IEEE recently, and we are founding the student branch. So that's a very good news from you as well, and confirmation that this organization is valuable for us. Now I'll switch to the next speaker. I'll switch for a bit in Georgian to introduce the next speaker.